Alright, hello there ladies and gentlemen. Today we're going to go ahead and make this part. We've got our instructions here asking us to create a multi-view part drawing for this part. Use the coordinate method for dimensioning angles and datum dimensioning. So here is our part. We've got this component, a 3D object. We've got an isometric view right here. You can see that we've colored different sides, different faces of the object, distinct colors, so it's easy to tell which face does what or is what. And let's go ahead and see what we're creating here. So the instructions say multi-view part drawing. So that means more than one view. Typically that's a 3-view drawing, and we're typically going to put our front view right down here, our primary view. Our primary view is going to go, let's go ahead and we're going to add 1, 2, 3 squares up, 1, 2, 3 squares over, and we're going to create our drawing starting right there. Now it says here we use the coordinate method and for angles and datum dimensioning. So that means I don't need a protractor. We're going to use the grid on the paper as our measuring tool. So 1 square is going to be equal to 1/4 inch. So these are 1/4 inch grid squares. So that will be everything we need to know about measurement here. We're going to get that information from here. So our object, here it is. We're going to use datum dimensioning. What the heck is a datum? Well, datum is a constant reference point, a singular reference point. So for this model, we'll go ahead and call this point right here our datum point. And we'll be able to reference that point in all 3 views that we create. And in our front view, the primary view, which is going to be the view we would see if we were standing here looking at the object that way. That is our primary view, and this would be our datum point. So let's go ahead and get that started. Now, before I even draw any views, I'm going to go ahead and create some baselines. Since now I have a datum point, I already know that the left edge of my top view is going to be right there, and the right edge, the bottom edge of my right view is going to be right here. So I already know, before I do anything else, this is where my project's going to be. Now I also know, since this is the orientation of the isometric view, that the white face and the red face are going to be in my primary view, going to be visible in my primary view. So I just got to rotate my block so that I can see the white face and the red face. And if I move that in front of the camera, you'll see that the only faces we can see in an orthographic view are the white and red faces. So let's go ahead and measure those and lay those out. The white face is 1, counting spaces, not lines, 1 space, 2 space, 3 space, 4, 5, 6 spaces tall. So we go 1, 2, 3, 4, 5, 6, and we're going to put our first point. From there, it's across 1, 2 blocks to the top. So I'm going to just go ahead and write that down so for reference later. So 6 and 2, so the length of that line is 2. So 1, 2. And the bottom is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Well, we said we were going to use the coordinate method for dimensioning. You're about to see exactly how that works. So now that we have the coordinates for all 4 points of this front white face, we're done. We can lay that out. We don't need to pull out a protractor to do any angular measuring because we know the coordinates of the locations of the endpoints of the line. So there is our first point, our first face, the white face. Let's go ahead and take a look at that red face. The red face is 1, 2, 3, 4. Additional places to the right, so 1, 2, 3, 4. And we're not going to measure along the angle, so we'll go down to the bottom. And 1, 2, 3. More spaces to the right on the bottom, so 1, 2, 3. And if we look up the red face, we can see that we go additionally up 1, 2, 3 spaces vertically. 1, 2, 3. And that takes care of all of the points we need to define our red space. There you have it. So there, ladies and gentlemen, is the outline for the front view, or primary view, of this object. Alright, let's go ahead and take a look at the right view. The right view is going to be what you would see if you were standing right here looking that way. If I come over here and take a look at that, and put my fingers on it, put my finger on it, you can see what's visible in that right view. What's visible is the orange face, a little bit squished, the blue face, also a little bit squished, and the green face in its full, true size and height and width. We don't have the full, we have the full height of the orange, but we don't have the full length of the orange. We have the full height of the blue, but we don't have the full length of the blue, because the blue length is measured that way. But again, we don't care about that. What we care about is the height and width. So we have a vertical face here and a vertical face here, so we're going to go ahead and start off by drawing the right vertical face, or in this case the back of the object. We'll just go in 3, 1, 2, 3. We went in 3 on the left side, we'll go in 3 on the right side. So 1, 2, 3 squares. Of course, how long is that line going to be? Well, this is where we already have that information. We don't need to do any more measuring because we have done it in our front view. So we can just project across. And now right there is the top right corner of the object. Right here, as we already established, is the bottom. And here's the only other point to transfer across. Right here. So there is all of our vertical the y-axis information. All our up and down measurements are now located. So bottom, middle, top. How wide is this? Well, this we haven't measured yet. So let's go. We have the straight line here, so let's go ahead and measure there. That's our widest point. So 1, 2, 3, 4. Let's go ahead and write that down. So transfer that measurement. 1, 2, 3, 4. And so we know that the overall width of this object is 4 blocks wide, and that the height matches the height we already measured, and we know that the views align with each other. Not quite ready to put this line in yet, because I know I have a straight face here, I know I have a straight face here, but wait a minute. A rectangle here and a line going across. We've got to figure out where that line is. Oh, we already measured that, and we know that it's 3 blocks up. We have our line here, but we don't know how deep it is. We know it's going to be a rectangle face for the orange, so we got to figure out how wide that orange face is. And the orange face is 2 blocks wide. So over 1 over 2. And now we have the information to know how wide the line is for the green and blue separation. And there you have it. So now we have our front view, our right view, and it's time to go ahead and produce our top. Well, we already know the left face. The top view is going to be what we see. We're standing here looking down at it. So that's going to show us the yellow, the blue, and the orange faces. So let's project that information that we've already figured out up to the top view. There's the top of the white face. There's the bottom of the white face. Leftmost edge, rightmost edge. There's the end of the yellow face, and red, where the red and yellow face meet. And here's the end of the object. So look at this. We know we have a straight line that runs the entire length of the object. So we're going to have a straight line right here. Nice and dark, crisp and clean. How wide is this? Well, we already found that out over here. 4 blocks. So we're going to come down 1, 2, 3, 4. And then the width here and here. Again, those measurements have already been figured out. So we know that the width of the yellow portion and the orange portion and the blue portion are both equally 2. So we know that, let's see, our yellow portion right here, 2 blocks wide. We know that our blue-green portion is 2 blocks wide. We know that those are going to connect together. We know that our blue and yellow portions separate right here. There's the edge between the blue and the yellow. And here's that sloped face for the orange. And follow that up, and that ends right here. And it's flat on the side. So we extend that out. And there you have it. Those are all of the shapes that make up this object in 3 orthographic views. Now it's time to go ahead and start putting some dimensions on this. So the way I like to do this is I come in here and cover it up and start working from left to right. This is datum dimensioning. So here's my datum point, my 0 point. The 0 point, as we already identified, is this corner right here, is visible here, here, and here. And all of our measurements will be able to be measured horizontally and vertically from that point. So that's the same point shown in 3 places, 3 views. All right, so let's go ahead and get started. So the first point that we need to measure, of course, is the beginning, that data point itself. So let's go ahead and put that in marker so you guys can see it. And then we're going to move across until we find our first measurement point. Here's our first measurement point. We have to decide if we're going to put it in the front view or the top view. Well, this point is more descriptive of what we have, so we'll go ahead and put that measurement right here. And 2 squares. Remember, each square is 1/4 of an inch, so if I have 2 quarters, I have 50 cents. So 0.50. Let's do a nice, neat job putting our arrows in place. Dimension arrows are really important. We want to make sure we touch the object. It gets really confusing, or touch the extension lines, because it gets really confusing when those aren't drawn neatly. All right, so there's our first measurement. Moving our way across, let's find the second one. There's our second measurement, so there's the end of the slope. All right, so again, I have 2 choices. Can I put it in the front view or the top view? Both of them do a decent job of showing us where the end is. However, if I put it in the front view, I'm going to cross the view, so I'm going to put it in the top view, so I don't have to cross the view. I'm going to measure across. That's 1, 2, 3, 4, 5 quarters of an inch, so 5 quarters is $1.25, so 1.25 all the way across. And again, make sure those your dimension lines touch your extension lines. Nice, neat arrowheads. Make sure our extension lines do not touch our object. Move it further across. You can see there's the next point that we have to touch. There's our next measurement. More clearly visible in the front view, so we'll just make our first extension line a little longer. And our second extension line goes here. And our measurement across, 1, 2, 3, 4, 5, 6. 6 quarters makes $1.50. 1.50. I'm not going to drop that 0, because if we're measuring to the nearest 0.25 or 2 decimal places, we're going to keep that same level of precision throughout the entire sketch. There you go, we're going 50, work our way across, and now we can put the total measurement in either the front view or the top view. I prefer, if I don't have a good reason to switch, I prefer to have my overall measurement in the front view. And right now I don't have a good enough reason to motivate myself to change that. So count that across, 1, 2, 3, 4, 5, 6, 7, 8. Makes 2. 8 quarters is 2 on the nose. Again, nice and neat arrows. Make sure our dimension lines touch our extension lines. And those arrowheads should be nice and neat. So those are all of our horizontal measurements that measure the width of this object. Let's go ahead and measure the depth of this object. The depth of this object is going to be measured, the depth and the height will be measured from this bottom datum point. We'll work our way up. So let's see, well, there's the bottom. Work our way up to the first corner, and there's our first corner, and you can see the better placement is either, so my choices are in the front view right here, and the right view on the left side in between the views, which would cross that view, or on the right side outside the view, which is not preferred. So let's go ahead with right here. And 1, 2, 3 squares. 3 quarters is 75 cents. So 0.75. And I can't really do a neat job putting the arrows inside, so I'm going to put the arrows and dimension lines on the outside. Working our way up. And I can put this in either view. Go ahead and put this here. And 1, 2, 3, 4, 5, 6. So that's 6/4 makes 150. There's the overall height. It did cross this dimension. Could have put it over here. But we're about to find out that would be the only dimension on that view. So I don't know that I really even need that view. So let's come on up and continue measuring. So that's all of our height measurements. There's no other vertical height measurements. So let's go ahead to our depth. And we can apply the depth measurements in either the top or the right side view. But right now I can see that the best place to measure the width of this orange face is going to be right here, because that's where it's most clearly seen as a depth. And it's 2 squares, so 0.50. And the overall width, or I'm sorry, overall depth is 1, 2, 3, 4 squares, so that's 1 inch, 1.00. And those are all of the dimensions I need to finish out this drawing. There you have it. Got all of my height measurements are dimensioned. All of my width measurements points are dimensioned. We've used the coordinate method for locating the ends of the lines. And we've measured from a datum point. Now by this point, you notice I didn't wind up putting any measurements on the right-hand side and no dimensions over here, so I guess technically speaking, I could just erase that view. If I'm doing this in CAD, I just delete that view, don't need it. Now if I really want to be a purist, I guess I could put this height measurement over here so that that doesn't cross. I think the opportunity to eliminate an unnecessary view outweighs having just a singular cross dimension, especially when it comes to the overall height and width. So that's what we wind up with. And there's dimensioning for that object. Hopefully that helps you guys out. Have an awesome day. As always, keep being awesome.